Okay, HTML entities. So, some characters, as in characters on your keyboard, have special meaning. And one of them that in HTML, one of those that we've seen, and indeed in all programming languages, they're characters that have special meaning. So, for example, the greater than and less than sign is used to represent, to bracket the tag names. So when the browser sees a angle bracket, it will interpret it as this should be the beginning of a tag of some kind. And if it finds a greater than sign, it would assume it was it's the end of a tag of some kind. But sometimes we actually want to put greater than signs, less than signs. Oh, can somebody get the door? Cheers. So sometimes we actually want to put these symbols in, and we have to use what's called an HTML entity or an HTML special character. So, angle brackets. So if you want to say, display x is greater than 5, we can't use the greater than sign. Instead, we use the code for the greater than sign, which is ampersand GT colon. All of the tags, all of the entities start with an ampersand and end in a colon. So GT greater than 5, and that gives us the text, x is greater than 5. Another example of an HTML entity is ampersand NBSPA, which stands for non-breaking space. So in your HTML document, you can format it with space. You can include space just to help you format it and make it look nice, just like you use space in your SQL queries to line the different bits of your SQL queries up. But you don't want all that space then to be displayed in the browser that's reading that web page. So what happens is that the web browsers collapse all what we call white space, which includes individual space characters but also tabs, into a single space, white space. So if you want, in fact, 2 spaces next to each other or 5 spaces next to each other, what you have to use is this non-breaking space character. And if you wanted 5 non-breaking spaces, you would need 5 of these in a line. And that would give you 5 empty character spaces. Here's some other commonly used entities. Let's have a guessing game. Anybody want to know what that one is? AMP. What character might that represent? Ampersand, yes. The ampersand. Yes, quote marks. I'm not sure whether they're single or double. And the last one? That's what it says, but what symbol would it produce? Copy. The copyright symbol, the C in the circle. Okay, so there's odd characters as well, things like that you might want as well. So have a look at that. Okay, tables. This probably should have come before the entities, but never mind. Tables are easy. We've got, we should have had the table one, first of all, which defines a table. Then you have TH, which defines header cells, TR for table rows, TD for cells in a table. Well, that's all very well, but what does one actually look like? So here's a table. There's our table. Starts there, ends there. In this case, I've got border 1. I've set the attribute for the border to equal 1, which means draw a border. And there we've got a table. So our top row is within these TR, the first set of TR headings, so row. And it's a header row. So we've got the word fruit and the word weight. So that one goes in the first cell. Weight goes in the second cell. Then we have a second row. The first cell in the second row contains apples, the second one a value. That's tables. They're that easy. There's a lot of, I must say, tables, they're easy, but if you've got a large table, they're actually quite hard to, especially if you're wanting to merge cells in tables and things like that. It can be really quite fiddly or take a little time to get complex tables together. HTML also supports a set of elements called form elements. And you'll be meeting these when you're starting to build your JavaScript web programs, because these are provide the tools that some of the tools that you might want to use to interact with the map with. So this thing, HTML elements include things like buttons, pull-down menu lists, areas where you can type text, sets of radio buttons, all the things that you're used to seeing on a web form. So here we've got a couple of text boxes, one where you enter the name, one when you enter an email, a comment box, and a submit button at the end to submit the form to wherever it's going to go. Where do the information go to? Well, there's two places it basically can be used. It can be either posted to a server to get some kind of response. So this may be your Amazon and you're filling in your address, your home address to get your order delivered. And then when you press that submit button, it would get sent off to the eBay server or whatever, or Amazon, wherever it was, and then the server would process that record, do your purchase, and then send you back a confirmation or a denial, depending on whether the payment went through. But this kind of information in these fields can also be used within the page to interact with the page itself. So, for example, we could type a name and an email, and that maybe provides something, gets added to something on the page rather than being sent off to a server. So it provides a set of widgets or tools which allow the user to interact with a page. Now, what the consequences of that interaction are is a different matter. Here's the kind of code that you get to create this form down here. So this is the code that's required to create this form. You can see you've got what's called an input box. Here's the input box. The name attribute gets appended to the left hand. Oh, sorry. The name, start again. So we've got the name text here. Then we've got the box, the input box, which is of type text. There's a variety of different types of input boxes. It's got a name called name, and it's got an ID called name, and its value is the text that's inside the box. So if we wanted to put a default value in, we would put it in that value section there. Okay, we'll see some of these in due course. I'm not going into the details. Okay, that's HTML. Now, HTML has a lot more to it than that, but that's all you really need to know for probably what you're doing, what you're going to do. We're not here. You're not here to learn to be web developers per se. You're going to learn enough web development to be able to make web maps, which is what you're here for. Okay, so HTML, as it was originally formulated and still used, mixes content, text, images, sound, video, with how that content is arranged on the page, the styling, the design. Now, many organizations have corporate styles. They want all their web pages to look the same or similar. Very understandable. Now, if you've got a big company might have thousands, tens of thousands potentially of web pages to manage. And if the formatting is embedded in all those text all embedded in the HTML text file, that means every time they want to do some change on the formatting of their web page, their corporate style, they have to go into all those thousands of web pages and manually edit them, or run some kind of program that then runs through all these styling tags and styling information in all the web pages and updates them all. A huge and problematic undertaking. And actually, of course, many of these pages are now automatically generated from databases, as we'll see. So then you would have to update the code that generates the things. Anyway, so you had this information where you have this situation where you've got one set of styling, 1 million web pages. You don't want to repeat that styling 1 million times for each web page. It's just going to be an absolute nightmare. So if we can separate the style from the content, then we've got one file for 1 million pages that defines the style for all those 1 million pages, and all we've got to update is that one file, and the whole all the other pages, it propagates to all the pages that use that file to style it. That's the idea. So from that, so to allow that, a language was invented, created, called Cascading Style Sheets. And this is basically a styling language. It's a language that tells the browser how to style the contents of the web pages. So what we do is we store the presentational settings in a separate CSS file that can be applied to any page. So the page has a link tag in the header, and that points to these style sheets which are loaded up for that page, so that you need one line of code to read all the style from a particular file. It not only allows us to update millions of pages by editing one file, all the pages that reference that style file, it also allows us, for example, to do different stylings for different types of users. Perhaps visually impaired users maybe want a different style, so we can have a button that perhaps implements a different set of styling to that page if you're visually impaired and press the button and want to see large text or something like that. It also means, because we've taken a whole load of styling tags out of your HTML file, so your HTML files are smaller. And if you're reading multiple HTML files from the same computer which reference the same style file, the first time you load one of those pages up, the browser will grab the style file, but the next page, instead of having to get the style file again, it's already got it in the browser cache and can use it. So it results in faster starts, as the style has to be only reloaded for one page and then can be used in subsequent pages. And it also increases the readability of your HTML code. There's less code, less different types of tags, easier to read code. So it has some advantages from the developer side as well as the management side. So CSS works like this. Basically, you can write it in several different locations, which you'll see in the practical. But one way is it can be written within a style tag within the header section of a page, and in that case, that style only refers to that page. So if you're just writing a single standalone page, you can do your CSS in the header section of the page. But you can also reference an external CSS file, which is the more usual way of doing it, and multiple web pages can reference the same external CSS file. Styles can be defined either for individual elements or for groups of elements. So there's a tag called class, for example, that can be applied to just about any HTML element, and therefore you could apply that to a paragraph, you could apply it to a box, you could apply it to a table border, or a table. You could apply that class to many different types of objects. And then each of those HTML elements share maybe a color method. Remember, methods and objects. So if you set the color to red for all that class, the color attribute for those different elements will be set to red. So the text may go red, the border of the box may be filled in red, and the external border of the table may draw in red, depending on what the color attribute does for that particular object or element in your web page. Right. And it's really quite a complicated language, a powerful language. I really am not a CSS. I know very little CSS, I hasten to add. But it allows the definition of really complex styling instructions, such as make the first letter of the second word in the third paragraph 64-pip bold. You can define stuff like that that's applied across web pages. So not just turn the ID 5 red, here's a little mini program for identifying sections of the text and doing particular things to it. Here's an example embedded in the style tag in the header. So here's our head to our web document. We've got our title. We have a style tag. It's got an attribute type telling us it's a text CSS style. Then within that tag, between the start and the end of those style tags, we have the CSS written. In this case, we're referring to body. So this is going to style the entire body section of the HTML page. It's setting the color parameter to purple. To be honest, I can't remember what purple color on a body of a document does. Can't remember off the top of my head, but the background color is being set to this. Does anybody know what that is? White. It may be, I have no idea, but what more generally? It's a hexadecimal or HTML color code. So basically all the standardized colors have what's called an HTML code. And if you search for HTML color codes in Google, you'll get lots of websites where you can pull a picker around and it will give you that color code. They're used in lots of graphics programs and things like that. So basically this is a number that sets the color of things. And there's loads and loads and loads of these, dozens and dozens of these. And these, so you can either use predefined names which map onto particular color codes, or you can actually specify a particular color code which gives you total control over what color you're actually going to use displaying. So here's an example. Right, here we go. So here's what in one of these online code testers. So here's we've got a body, we've got a style tag, the background color we've set to that, whatever that is. I can't remember the same one. And we can see it's a kind of pale blue, pale grey blue. The header 1, the first header, here's the header tag down here, first CSS example. We've set the color of the header to red, and it's written in red. Surprise, surprise. We've also set the size of the font. We've set the alignment to center, so it's in the center of the page. The paragraph underneath, we've made it in Times New Roman font and size 20 pixels. So that's a little example of CSS. That's CSS embedded within the HTML file. And as I say, that's fine if you've got one page that you want to style, and you're not going to use that style anywhere else. But if you're using the style in more than one page, which is quite normal, or you simply want to separate the CSS from the HTML to end up with a smaller file, so you don't have to scroll up and down so much. And I do this by standard just about no matter what I'm doing. Unless I've only got 2 lines of CSS for one page, I'll put it in a CSS file. So in this case, we have a link tag. It has the rel attribute, which says it's a style sheet, and then the href points to the address of the style sheet. Again, this is just in the same folder on the web server as the web page that's referring to it, but that CSS file may be anywhere on the internet. So you can put a URL in there, and it can be anywhere on the internet. Okay, so that's CSS. That's all I'm saying on CSS. So the third component of a web page is, well, web pages written in HTML and CSS are static. They load it up, they're on the page, and they sit there looking at you, or you sit there looking at them, as the case may be. So you can't point and click on them, you can't do anything with them. The only thing you can do is if it's set up for there's a form with a submit button that's set up to be sent to a server, then you can fill up that form, press the button, and go to the server. But you can't do anything internally. Within the page itself, it's static. It can't change. You can't sort of turn off bits of, make a field so that you can't enter data into it, or automatically fill the value of a field or anything like that. That's dynamic, that's movement, that's change. So if we want dynamic pages, our pages to be able to change while they're in the browser, once we've grabbed them and loaded them up into our browser, so we can interact with it or have some kind of animation or something like that, we need to write programs to embed programs within the web pages. And These programs can do things like alter the page layout and content, allow user interaction, point and click on things, request data from a server, display complex graphics. It's a programming language. It can basically do anything you want within the structure that you have, the HTML, CSS structure that you have. So, and these programs come in a variety of programming languages. The most common and widely used is JavaScript, which is what we'll be using. But you also get these programs written in things like Flash. I'm sure you're used to Flash animations. That's an example. That's also something that's running in the browser. Java, Microsoft Silverlight, you may have come across. Now, the difference between Java and these other ones is Java comes ready wrapped in every browser that's distributed and is a WC3 standard. So JavaScript is basically read by all browsers. For these other ones, ActionScript, Java, Microsoft Silverlight, as you probably discovered, you need to download and install the extra program for you to run it within the browser. So so JavaScript basically is really closely linked with the World Wide Web and browsers. These other ones, you can use them, but they require, for example, permission for people to install Silverlight or Java or something like that. And if you've heard things like ActionScript and Flash, various companies are trying to get rid of them because of the security holes in them and things like that. So here's an example. This is an example of the OpenLayers web mapping program, which is a JavaScript library. It's basically the rival to Leaflet. That we're going to use. Leaflet's a sort of slim and quick, small mapping library. OpenLayers supports much more functionality, but it's a much heftier piece of software to develop with. So if we want to do things like include mapping interfaces with buttons that we can zoom in and things like that, they're mostly written in JavaScript, but there may also be ones in Java, Microsoft Silverlight, things like that. Okay, just to finish off. So browsers and HTML, or browsers and web languages in general. So the program, the HTML page, the CSS, maybe some JavaScript, gets sent from the server to the browser, to the client running on the client machine. And that code must then be interpreted by the browser in order for it to display whatever it's going to display on screen and do whatever it's got to do if it's got a program behind it. But all browsers are different, and not all of them implement what the WC3 standards for HTML, CSS, or indeed JavaScript. So basically, if you write a program and send it to a particular browser, there's a possibility that that browser won't support the code that you've written. This is not a common problem. Well, when I say common, it depends what I mean by common. How often does something become common? It's something you must be aware of. And whenever you write an application, develop a web application, develop a web page, you should try it out in different browsers. Because you may find that while it works, maybe you're developing in Chrome or Firefox, and then you load it up into Microsoft Edge, and it's going to look like a dog's breakfast for some reason. So do try it in different browsers, and if you don't have to check whether there's a problem or not. So each browser has its own idiosyncrasies, things that it doesn't quite support, or it does in its own particular way. And the prime culprit for this is Internet Explorer, Microsoft Internet Explorer. There are lots of little workarounds that have to be done to make sure that certainly bits of CSS and particularly JavaScript work in both, say, Chrome and work in Internet Explorer. I don't know what the new Edge one is like, whether it solved some of those problems or not. So bear that in mind. Not everything works exactly the same in all browsers. And you may need to implement some sort of browser-specific code that says, if it's this kind of browser, then do this, but if it's otherwise, do this. Okay. Code. So I tend to write most of my code in a text editor, a plain text editor. To a certain extent, this just reflects that my programming is, I wouldn't say it's beginner program, but I wouldn't say it's expert level either. It's somewhere in the middle. Most of the stuff I build are sort of small to medium-sized applications. I'm not running corporate systems and things like that. I don't have a high demand on fancy CSS and fancy graphics on my web pages. They're generally pretty basic. So I tend to write my code in Windows. I use a thing called Notepad++, and of course you can use Medit or whatever in OSGeo Live. So I just tend to write and organize my code, my HTML code like this. But there are, of course, numerous fancy programs, content editors, probably the most famous one being Dreamweaver, that provide graphical interfaces for designing and managing web pages. I think Dreamweaver is available from the self-service applications. So in this case, you can see you've not only got the code panel, but you've also got a layout where you can graphically drag and drop individual items. You can set, there's a sort of more of a GUI-based environment for setting parameters and things like that, whereas here you'd actually type it individually in code. So for those managing large websites, complex websites, it's probably something like one of these content editors is more suitable than a raw text editor. Most of this, I wouldn't bother yourselves writing raw text. The other thing about writing in raw text is that you have complete and utter control about what you can write. I'm sure Dreamweaver is spectacularly good at most things, but when you tend to use these in development environments, I find that you often find that they do 90% of what you want, but not the other 10%. And depending on how difficult it is to implement that extra 10%, you might end up wishing you'd never used this thing in the first place. So just bear that in mind, that there is some, if you've got some sort of special functionality that you want to try and implement, it may not be implementable within these things. So just bear that. I'm sure Dreamweaver probably just does just about everything, but I've certainly used editors like this in the past and then discovered that, frankly, it's easier or just as simple. And I also, typing it, you actually learn what you're doing in the code, whereas here, the code itself is hidden. It's writing the code for you, basically, through a graphical interface. So if you want to learn coding, do that. If you're more interested in getting web pages up and being a web designer, sort of from a graphic design perspective, you may be better using something like Dreamweaver. Viewing your HTML source. All right, we've already seen this. You open your URL in your web browser. You then right-click in most browsers and view page source, and that will open up just another tab that allows you to quickly see the text here that's behind. There's the page. There's the text. So if you want a quick glance at the source code on any web page you like, right-click and view source. You will only see the HTML here. The web page may be made of lots of other bits and bobs, but because you're only seeing the HTML source here, you're not seeing perhaps if you've got an external link to a CSS, you won't see the CSS file. You'll just see the HTML. Chrome, Firefox, and some other browsers also have an integrated development environment embedded within them. Now, these are really, really useful, and I'm still learning how to use this development environment. Is this one in Chrome or is this in Firefox? I don't know off the top of my head looking at that. But if you right-click on the document again, and then you choose the Inspect Element option, it opens a window underneath, and this is interactive. And I can go around and I can point and click with the mouse and I can select that paragraph and it will select up in the web document itself. So I can map my code here into what I actually see on the screen, and that's incredibly useful. I can also access the sort of various bits of it. I can burrow in hierarchically down into the page. I can also go onto sources and access the CSS files that I used for that. And indeed other people. I think you can access remote CSS files as well. You can actually run debugging of JavaScript in there. It's pretty much a full development environment, and it's well worth learning how to use that, because learning how to debug is as important as learning how to program in the first place. It's all very good writing code if it then doesn't work. Okay, so that's pretty much it. So just to sort of summarize, when you think I'm going to make a web page, that page must have some kind of content written in HTML. That HTML may be dynamically written by a program, and we'll meet that next week when we'll talk about in architectures, computer architectures, computer hardware, software architectures. Modern web pages would also have CSS associated with it for styling, but as I said, there's a lot of pages out there which don't use CSS for styling. And the third thing that it may have is some kind of dynamic action written in JavaScript. So a web page is going to be HTML, maybe HTML and JavaScript, maybe HTML and CSS, maybe all three together.